Hey everyone, and welcome to this explainer. If you're gearing up for your science exams, and let's be honest, feeling a bit overwhelmed by the absolute mountain of facts and formulas you have to memorize, you are in exactly the right place. Today, we're stepping right through the fourth wall of your textbook. Look, I know that when you're 15 or 16, science can sometimes feel like just an endless list of things to cram into your brain, but my goal today is to help you quickly revise the foundational mindset of your science chapters, breaking down exactly how all these complex topics actually connect. We're going to cover the wonder of science, how different subjects link together, everyday scientific mysteries, and finally, how to ask the exact right questions. We're looking at the big picture here, so that when you sit down for those exams, you aren't just reciting data from memory, you actually understand how the world works. So, let's get curious.
Okay, let's dive into this. Imagine this situation. You're just messing around, watching some kids play with paper planes. Did you know that something as simple as observing a paper plane in flight is literally what inspired early inventors to study bird wings? And that eventually led to engineers building the modern aircraft we have today. It's true. Science always starts with a simple, everyday observation. When you're revising for your physics or mechanics exams, just remember that every single complex aerodynamic equation started with someone throwing a folded piece of paper and asking, wait, how does that actually stay up? Let your imagination take flight as we go through these concepts, because honestly, that curiosity is your absolute best tool for learning. All right, let's hit our first major theme, the wonder of science, which is really just an invitation to question. You see, science isn't just a static dictionary of terms. It's an active, ongoing process of discovery. And even more than that, it's about environmental responsibility. As young scientific thinkers, everything you learn about, whether it's ecosystems, thermodynamics, or chemical reactions, it's all linked directly to what happens in our natural world and our society. Understanding this helps you see the actual role science plays in solving real global challenges. And heads up, examiners absolutely love to ask about this in application-based questions. Like this quote reminds us, this again is not just a textbook with facts. It is an invitation to question, to perform experiments, and to explore. The goal isn't just to memorize your notes and regurgitate them onto a test paper. It's an invitation to step out of the classroom, mentally if not physically, and explore the beautiful world we live in. When you treat your syllabus as an invitation to understand your environment rather than just a chore, I promise you, the concepts stick in your memory so much better. Let's understand this simply with a great little pun. To be a wise person, you must be a wise person. Okay, I know it's a bit of a dad joke, but I absolutely love it. Asking why is the foundation of all scientific exploration. Why does the apple fall? Why does ice float? Why does cells divide? If you can get into the habit of just asking why while you're revising, you'll easily transition from rote memorization to that deep, exam-crushing understanding we're looking for. Moving right along to Section 2, Exploring the Natural World. We're going to see how science is totally interconnected.
Yeah. During your exams, you might take a physics paper one day and a biology paper the next, so they feel totally separate, right? But nature doesn't organize itself into neat little school subjects. Think about physics, chemistry, biology, and earth sciences. While they seem like completely different blocks on your timetable, they are constantly interacting out in the real world. A discovery in chemistry, like understanding how a specific protein folds, instantly inspires massive breakthroughs in biology. Understanding the physics of heat flow, well, that's essential for mastering earth sciences and studying things like global warming. This is very, very important for exams. Whenever you can show your examiner that you understand how a chemical concept applies to a biological system, you are demonstrating top-tier knowledge.
Our exploration of the universe scales all the way from the totally microscopic to the incredibly cosmic. Science asks us to look at tiny cells inside a leaf and then zoom way, way out to observe the vast, sweeping movements of the sun, the moon, and the stars. Whether you're testing materials at home or analyzing how water flows underground, it's really all part of the exact same grand puzzle.
Which brings us to Section 3, Everyday Science Mysteries, or the questions all around us.
Let's bring these lofty ideas back down to earth with a rapid-fire question. Why are some fruits sour? Just think about it. When you bite into a lemon, that intense sourness is a direct, everyday experience of chemistry. You're actually tasting the properties of acids, specifically citric acid. This is a brilliant, super simple way to remember your acid-base properties for the test.
Next up, what happens when we wash a haldi or turmeric stain on a white school uniform with soap? If you've ever seen this happen in real life, you know the yellow stain suddenly turns bright red. But why? Well, because turmeric is a natural chemical indicator and soap is a base.
This is an incredibly common application-based question in chemistry exams. Chemical reactions are literally hiding in plain sight, right on our clothes. What about physics? What materials do we actually need to make a lamp glow? Well, you need a power source, conductive wires, and a filament. And this leads us directly into classifying materials into metals and nonmetals, or conductors and insulators. It also makes us think about changes, like when a battery runs out, it can't be used again, right? This perfectly illustrates the concept of irreversible chemical changes versus reversible physical changes, like ice melting into water.
Let's expand our scope even further here. How do we measure the passing of time? Long before we all had digital watches, early humans used the sun to tell time by observing shadows. Think about how fast things happen in nature. Think about heat flow, the water cycle, and how evaporation eventually brings us rain. Asking questions about simple shadows directly leads us to asking questions about the very nature of light itself.
So the crucial point is this. Starting with a really simple question about a glowing lamp or a shadow on the ground eventually scales all the way up to understanding how the Earth rotates on its axis, how the Moon orbits the Earth, and how planetary eclipses work. Asking questions about light helps us understand the delicate balance of day and night on our beautiful planet. See? Everything connects. Let's do a really quick recap. We've seen that science is an invitation to explore, that subjects like physics and biology are deeply intertwined, and that everyday mysteries, from sour lemons to shadows, are the real key to grasping massive scientific concepts. If you remember these connections, revising those complex chapters becomes an absolute breeze.
All right, our final section, Part 4, Questioning the Answers, where we are flipping the script.
To wrap up today, let's do a quick exercise to really test your scientific thinking. In exams, you're pretty much always given a question and asked to find the answer. But true scientific genius actually works the other way around. Great scientists don't just answer questions, they ask amazing ones. So instead of finding the answer to a question, we are going to invent the question for a given answer. This forces your brain to think creatively and critically, which honestly is exactly the kind of mental flexibility you need to tackle those tricky, unexpected exam questions. Let's try it out.
Okay, here's your first answer. Because the cat's teeth were crooked. Now, I want you to let your imagination run wild. What could the question possibly be? Maybe the question is, why did the veterinarian recommend braces for the feline? Or, I don't know, why did the cat leave such a strange bite mark on my homework? Thinking like this trains you to look at data, the answer, and deduce the initial conditions, the question.
Let's try another one. The answer is, just add some milk. So what's the question? Maybe it's, how do I neutralize the intense spice in this curry? Or if we're thinking chemistry, what is the simplest way to demonstrate a colloid solution? See, there are no wrong questions here, just opportunities for fun, creativity, and applying what you already know to totally new situations.
All right, let's do one last famously cryptic prompt. The answer is simply 42. Now, try to think beyond basic math, like what is 40 plus 2? What scientific question could possibly have 42 as the answer? How about, how many teeth does a dog have? Which is actually true, by the way. Or maybe you're a big sci-fi fan and you're thinking of the ultimate answer to life, the universe, and everything. The whole point here is just to exercise that curiosity muscle.
Which brings us to our final takeaway. What beautiful mystery will you observe and question today? As you close this explainer and head back to your study desk, don't just stare blankly at the page. Look out the window, observe the world around you, and ask why. Connecting your textbook to the real world is the ultimate cheat code for acing your exams. Now you are totally ready to revise this chapter quickly and effectively. Keep questioning, keep practicing, and good luck with your studies.